Sorry about that, guys. Looks like we had a technical problem and my camera sort of stopped recording. So to recap what we were just doing, we're almost done the lesson anyway, so we're gonna wrap it up in a sec. What we had just now is we're talking about the slope of a vertical line, right? And so we said that the slope is undefined. Now, the reasoning behind why we can't just write down infinity is a little bit more complicated than what we're going to try to get into today, especially because I do want to make sure that we actually get a chance to talk about negative slope. So let's take a few minutes now to discuss negative slope, but just as you know, so that you have something to write down in your notes, because I have been just just talking for the most part in this video. So for a horizontal line, your slope is equal to 0, right? So that's an important point. And basically, your equation of a horizontal line would look like something like y equals, and then if you had mx plus b, but m is equal to 0, then the only thing that's going to survive, so if you wrote it as mx plus b, and m is 0, this whole thing is 0. So you're just left with y equals b, where b is some number. So b could be like 3. So you've got something like y equals 3. That means that no matter what your x-coordinate is, your y-coordinate is always 3. No matter what, it's always 3. So you might as well just draw your perfectly flat line at y equals 3. And the x-coordinate doesn't matter whatsoever because it doesn't even show up in your equation. So for a horizontal line, the equation looks very, very simple. For a vertical line, don't worry too much about the equation, just because we're not really going to worry about that in the remainder of this unit. But for a vertical line, what you should know is that, let me get rid of this. For a vertical line, because that's what we've been working with so far, your slope is undefined. So we're not just going to write down like infinity or anything like that for the slope, but just know that for a vertical line, your slope is undefined. And so let me explain why it's undefined. So if we revisit the sort of the mathematical way of defining the slope, so we've got m is equal to y2 minus y1 over x2 minus x1. Let's look at this vertical line that we've got right here. So this is the line that we're interested in. If we look at any 2 points that are on this line, assuming it's a perfectly vertical line, their x-coordinate is going to be the same. How far over we've moved from the origin is going to be the same. So this distance here is going to be the same as this distance here, right? So that tells us that our x-coordinates are going to be identical. Now that's a little bit of a problem, because if our x-coordinates are identical, then when we do this subtraction over here, we're going to get some number, like if this number is, again, let's just say 3, then this is also 3, right? So we would end up with like 3 minus 3 on the bottom, which means that we're going to end up with m equals some number, who cares what it is, we'll put a question mark there, over 0, right? Because we would end up with a 0 for the difference in our x-coordinates, because the x-coordinate is the thing that remains constant for a vertical line. Now that's a little bit of a problem, because we can't just say m is equal to infinity. That's not going to work for us. And the reason that that's not going to work is, let's bring this 0 over to this side of the equation. So if we bring this 0 over, right now it's being divided on the right side, so when we bring it over to the left side, it's going to be multiplied. So our equation is going to look like 0 times m is going to equal, well, whatever the difference in the y values is. So like if the difference between those two y values is, let's say, I don't know, 2, then we would have 0 times m is equal to 2, for example, right? So 2 would be our change in the y-coordinates. So like these 2 points right here would be some number that's not going to be 0. So 0 times m is equal to some number that's not 0. is there any possible number that we could multiply by 0 and still get a non-zero answer? And obviously the answer to that is no. We can't multiply 0 by any number and get a non-zero answer. So there's no number that we could put in place of m here, not even infinity, that actually satisfies that equation, which is why we're not dealing with the equations of vertical lines, but also why we can't simply state m equals infinity, because even m equals infinity doesn't satisfy this equation right here. And so that's why it's a little bit of a problem, and we write it as an undefined slope, which you could, as like a shorthand, if you don't feel like writing undefined the whole word, UND is also fine, if you'd prefer to write that. Now the last thing we have to talk about is a negative slope, and I think you can guess where this is going, simply if we draw out a little Cartesian plane and look at some of the examples that we've dealt with so far. So if I draw out something like this, we've got the grid. So if we've got a number with if we've got a line with a positive slope, it might look something like that, right? A line with a slope of 0 might look like something like this, and a line with an undefined slope might look something like that. I know I've drawn a lot of lines on this already. Here's our x-axis, here's our y-axis. I'll just put some tick marks so that you can see which ones I mean to be the axes, but it doesn't really matter. A line with a positive slope would be like this. 0 slope is perfectly flat, and an undefined slope is this vertical one right here. So the only sort of direction that we haven't covered is a line that's going this way. And so these are the lines with negative slope. And we're going to talk about why. I'm going to get rid of this horizontal and vertical bit, and we're just going to touch on why negative slopes give us lines that look like that with a brief example, just so that you can get an idea of where the negative sign comes from, basically. And then in the next video, we'll do some examples involving negative slopes. So in this one, I really wanted to touch on the concept of the perfectly horizontal and perfectly vertical lines as well, but we'll do the we'll just sort of touch on negative slopes right now. Oops, there goes my my marker cap. We'll just touch on negative slopes right now, and then we'll really work with them more extensively in the next lesson. So let's draw out. I'm just trying to get my marker cap back with my foot. Whatever, we don't really need it. So let's draw out. Let me draw out a little thing like this, and we'll just draw out a couple of tick marks in each direction because we don't need a lot to get this point across. So we'll label our axes like so. So if you can just draw out a couple of things like that, that should be enough. And let's put a point at 1, 2, so up here, 1, 2, something like that. Yep, and we'll put the other one at 2, 0. So we've got a point here. This is at 1, 2, and then this one over here is at 2, 0, like that. I've got my marker cap back. Excellent. All right, so if we've got those 2 points, then our line would run through both of those points, right? So our line would look something like this, which is not a direction that we're used to seeing our lines drawn in, right? Normally our lines have looked like that, and now they're all of a sudden looking like this. So this is kind of new, but let's examine the equation that we've used for our slope. And we can even look at this the non-mathematical way. We'll use rise over run to sort of get the point across, and then we'll examine this in more detail in the next video. So for this one, let's figure out the rise. If we're going from our first point to our second point, we can see that there is no rise. We're not moving up, we're moving down, right? We're basically falling 2 units and then moving over to the right. Right? That's one way to think about it. So the other way to think about it is that you're going from this point to that one, because then there's a rise, but then instead of moving right, we're moving to the left. So we'll think about it both ways. If we think about it the first way, with going from this point over here to that point over there, so let's label them. Let's say this is point A and that one's point B. Going from point A to point B, we have to first fall 2 units, so we have to go down 2 units, and then we move over 1 to the right. Well, hang on a minute. If our slope is going to be a fraction, if we're going down 2 units, that's the negative y direction. So I can put a 2 for my rise, but I have to put a negative sign with it as well. And then if I'm moving over to the right, that's fine. That's still the positive x direction. So I can put a 1 right here. So then my slope would be -2. I've got -2 divided by 1. Then over 1 doesn't change anything. The other way to think about it, so this is going from, the way we're thinking about it here is going from A to B. The other way to think about it is going from B to A. And so if you think about it that way, then that means I gotta get rid of this. And that means we start at B, and it's like, all right, we gotta go up 2 units, no problem. And then we have to go 1 unit over, but instead of going over to the right, we go over to the left. Now here, if we look at our rise and our run, the rise is definitely a rise. We are moving up if we start at point B, and we move up 2 units. Great, no problem. Then when we move over, we're moving over 1 unit, but we're moving in the negative x direction. So we're moving over 1 unit, but we have to stick a negative sign on it because we're moving in the negative x direction. And so what this lets us do is this lets us write out our fractions slightly differently. We've still got the 2 and the 1. The negative has just moved from one spot to the other, and doing 2 divided by -1 is still going to give us an answer of -2. So then there you go. That's showing you we get the same answer in both cases. So it doesn't matter how you think about it. Just be careful that you're not putting in too many negative signs, and make sure you're not putting in too few. Because if you're moving down and to the left, that's actually a positive slope. And I'm going to leave you guys with that to think about that until we get around to the next video, which will be coming around hopefully about this time tomorrow. I mean, hopefully a little bit earlier than this, but you know, this time tomorrow basically. Yeah, so earlier on, before the technical difficulties, we were talking about horizontal and vertical slopes, which I know they're a little bit more confusing, so if you didn't write down too much in this lesson, that's okay. As long as you're understanding the concept of horizontal and vertical slopes and these negative slopes as well, don't feel like you have to write down a whole bunch of stuff that I'm saying. As long as this concept is making sense, that's the important part, and we will really drive the idea home in the next video with a couple of concrete examples. So, if you guys have any questions, and it's totally understandable if you do, because we were talking about infinity and stuff today, let me know, but otherwise I will see you all in the next video. Have a good one.